All right. Well, we're going to continue on with polynomial functions and zeros. Prior, we learned how to divide polynomials. We did that with long division, and we did that with synthetic division. And we're going to expand on some new theorems. So the first theorem today is called the remainder theorem. So if you have a function that's divided by anything of the form x minus c, c being a constant there, then the remainder is f of c. Okay, and then the second one there is the factor theorem, which states if the remainder is 0, then x minus c is a factor. In other words, then that c value is a 0. Okay, so let's look at this first example here. Let's say you're given this function, f of x. Let's go ahead and use the remainder theorem to find the remainder when we divide by something of the form, when we divide by x minus 2. So here's our function, 2x cubed minus 4x squared plus 5x minus 3. And let's say we divide it by x minus 2. I'll do it with long division here first, and we can do it with synthetic division as well after. I'm trying to match that 2x cubed, so I'm going to say, well, 2x squared times x gives me 2x cubed, and 2x squared times gives me 2x cubed, and 2x squared times negative 2 gives me negative 4x squared. And don't forget, we got to change our signs on that. And so that's gone. And then we bring down the 5x, and we got to bring down a second one as well. So when we multiply, we have two things there. So in this case, we'll end up having to bring down both there. Now we're matching the 5x. So I'm going to go ahead and punch in 5. 5 times x gives me 5x. 5 times negative 2 gives me negative 10. Don't forget to change those signs. It looks like our remainder here is 7. There's our remainder, right? If we had done this with synthetic division, if we're dividing it by anything of the form x minus c, in this case it's x minus 2, we identify the c, so we put the 2 in the box. Then we use the leading coefficients 2, negative 4, 5, and negative 3. And this will be our remainder right there. We drop the 2 straight down. We multiply the 2 times the 2, which gives us 4. And then negative 4 plus 4 gives us 0. 0 times 2 gives us 0. 5 plus 0 gives us 5. 5 times 2 gives us 10. Negative 3 plus 10 gives us 7. So again, there's our remainder of 7, right? So we have a remainder of 7, which means 2, remember we were dividing by x minus 2, it means 2 is not a 0. So let's write that down. Since the remainder is 7 and not a remainder of 0, then 2 is not a 0. It's not a clean, nor is x minus 2 a factor, right? So it means x minus 2 is not a factor, and it means 2 is not a 0, okay? And now notice, we know our remainder is 7 here. If we had taken this original function, f of x equals 2x cubed minus 4x squared plus 5x minus 3, remember, we're dividing by x minus 2, so 2, we're trying to see if 2 is a 0 or not. Well, if you plug it in, this remainder theorem says, or I'm sorry, the factor theorem says if I plug the c value in, it'll tell you what the remainder is. So here we got 2 times 8, I got 16, minus 4 times 4, 16, plus 10 minus 3. Well, those are gone. 10 minus 3 gives me 7. That's my remainder. If you notice, that was our remainder, right? If we did it with long division or synthetic division. So since the remainder is 7, the remainder is not 0, then 2 is not a 0, right? Nor is x minus 2 a factor, right? Let's keep going with some more. So here says, here's given the function, find f of -5 first. So here's our function, 2x to the 4 plus 12x cubed, 6x. Find f of -5. Let's see, that's 625. It's -125. And that ends up being 0. So f of -5 equals 0. In other words, this hits. In other words, the remainder is 0, which also means that you have the point -5, 0. It's a 0, -5. So remainder is 0. So by the factor theorem, so -5 is an x-intercept. In other words, it's a 0. All right, let's do it the other way. Let's do it using synthetic division. So if we were to take the function and divide it by x minus the -5. In other words, I'm dividing it by x plus 5, right? So -5 is our c value. Remember, we're dividing by x minus c. So c is -5. Let's put our leading coefficients in here of each term. So 2, 12, 6, -5, and 75. And let's drop the 2 down. 2 times -5, -10. 2 times -5, -10. 6 minus 10, -4. -4 times -5, 20. -5 plus 20, 15. 15 times -5, -75. So sure enough, our remainder is 0. So remainder is 0, which also means not only is -5 an x-intercept, so it's an x-intercept, and x minus -5 is a factor of the original function, right? So it means it's a factor of the original function, x minus -5. So x plus 5 goes into it cleanly. Okay, let's keep going here. Let's solve this equation now. So let's use this information to solve. So it says -2 is a 0 of this function right here, right? So since -2 is a 0, then x minus -2 is a factor of 2x cubed minus 3x squared minus 11x plus 6. Okay, so they're giving us, they're telling us -2 is a 0 of it, right? So here, let's go ahead and, because what we're trying to do is we're trying to solve this equal to 0, right? So we have to factor it. So let's write this down. And they're telling us -2 is a 0. So x minus -2 must be a factor. Well, what's the rest of this then? Well, like if you knew, if you were factoring 12 and you knew 2 was a factor of 12, right? And you say, oh, well, I could do 12 divided by 2 gives me 6, right? So let's go ahead and divide 2x cubed minus 3x squared minus 11x plus 6 divided by x minus -2. And let's do it with synthetic division. So the -2 goes in the box. 2, -3, -11, and 6. We know it's a 0, so I know I'm going to have a remainder of 0 here when I do this. But I'm doing this so that I can find the other factor, right? So I'll drop the 2 down. 2 times -2, -3 minus 4, Negative 7 times negative 2. Negative 11 plus 14. 3 times negative 2. There it is. So when I do the division, I get 2x 1 degree less squared minus 7x plus 3. That's what I'm going to put in right there. 2x squared minus 7x plus 3. So now this is what we have. We have x plus 2, because x minus negative 2 is a factor. We have 2x squared minus 7x plus 3. Well, now I have a quadratic, and I can factor a quadratic, right? So I leave the x plus 2, and I'm like, okay, that's got to be 2x and x. I got to have factors of 1 and 3, so I'm going to try 1 and 3, or is it 3 and 1? And it's a positive 3, so it's got to be negative times a negative, or a positive times a positive. In this case, it's 2x minus 1 times x minus 3 gives me 2x squared minus 7x plus 3. And there's all my 3 factors. So then I say, oh, well, x plus 2 equals 0, 2x minus 1 equals 0, x minus 3 equals 0. So my answers are 3, a half, and we already knew the negative 2, right? So those are our 3 solutions. They already gave us the negative 2. Those are the 3 zeros. In other words, this function hits at negative 2, it hits at a half, and it hits at 3. Right? That's what this 2x cubed minus 3x squared minus 11x plus 6 function hits at, right? But we're just trying to find the x values for which it is equal to 0. In other words, where's the x-intercepts? Okay. All right, the rational zeros theorem gives you the number of possible, and actually this should say rational zeros. Okay. And it's the factors of the constant on the end over the factors of the leading coefficient. For example, let's take a look at this 3x cubed minus 7x squared minus 22x plus 8. Okay. This is a third degree, right? It's a third degree polynomial, so it'll have 3 zeros. Well, what are some possible zeros? What are some possible x-intercepts? Well, some possible, I'm going to use that funky looking Q for rational zeros, are factors of the 8 on the end over factors of 3, the leading coefficient. Well, if you think about factors of 8, right, it could be 1 times 8. It could be negative 1 times negative 8, right? It could be 2 times 4. It could be negative 2 times negative 4, also gives you positive 8. Factors of 3, though, are just 1 and 3, or negative 1 times negative 3. So to not deal with the plus minus, 1 or negative 1, what I'm going to do is I'm going to write plus or minus on each of these. So plus or minus, I'm going to start with, here's the factors of 8. These are all plus minus 3. So what I'm going to do is I'm going to go 1 over 1, and then 2 over the 1, and then the 4 over the 1, and then 8 over the 1. And of course that's plus minus. And then I'm going to go each of those over the 3. So plus minus the 1 over the 3, plus minus the 2, the next factor of 8, over 3, plus minus the next factor of 8 over 3, plus minus the next factor of 8 over 3. And then I just look and see if I have any repeats. And here I don't have any repeats, right? Like, let's say I had like 8 over 4, that's 2. Then I would have said, oh, that's a repeat because I already listed 2 over 1, right? So no repeats here. And these are all the possible places the graph could cross the x-axis, at least possible rational ones. All right, so let's go ahead for this one. Let's use that rational zero theorem and list the possible rational zeros, and then we'll go ahead and find them by testing for part B, okay? So possible rational zeros, the factors of the 20 on the end. Remember, it's plus minus, so I'm going to ignore the negative there. Over factors of the 1, which is the leading coefficient in front of that x cubed. Well, factors of 20, you got 1 and 20. You got 2 and 1 and 20, 2 and 10. You got 4 and 5, right? And factors of 1, of course, are just 1 and 1. So the possible rational zeros, I'm going to start with the 1 over the 1. I'm going to keep going plus minus 1 over 1. Then I'm going to go to the 2 over the 1. Then the 4 over the 1. 5 over the 1. The 10 over 1. And finally the 20 over 1. Okay, so those are all our possible zeros. And of course, I don't need to write them over 1. So just know that 1 over 1, of course, is 1. 2 over 1 is just 2. Let's go ahead and test them. So we need to test and find out which one of these is a 0. Okay, so I'm going to start with the negative 1 first. Is negative 1 a 0? So in other words, for this function, we're trying to factor it, right? Well, if negative 1 is a 0, again, well, if it does, it has to have a remainder of the 0. If it does, then x minus negative 1 would be a factor. And we'd put our answer right there, right? Whatever we get. Let's go ahead and see if it is. Yeah, let's see if it is. Is x minus negative 1 a factor? Well, I put the leading coefficients of the x cubed plus 8x squared, 11x minus 20. And let's see if it has a remainder of 0. Drop the 1 down. 1 times negative 1, 8 minus 1, 7. 7 times negative 1, negative 7. 11 minus 7, 4. 4 times negative 1, negative 4, negative 24. Okay, doesn't work, right? No, it's not 0. So x minus negative 1 is not a factor. So let me erase this. I say that's not a factor. So negative 1 is out. Negative 1 is out. So let's try positive 1 now. Let's try positive 1. If 1 is a 0, right, if I get a 0 here, then x minus 1 would be a factor. And I'd put my answer right there because I'm trying to factor this. So let's test it. Again, 1, 8, 11, negative 20. And let's see if this works. Drop the 1 down. 1 times 1, 8 plus 1, 11 plus 9. Hey, there it is. It is a 0. So then I say, oh, okay, well, then, oh gosh, erase that. There we go. Then my answer is 1x, 1 degree less, x squared plus 9x plus 20. That's what goes in right here, x squared plus 9x plus 20. Because what we did is we took x cubed plus 8x squared plus 11x minus 20 divided it by x minus 1. So we put our quotient there, okay? Now we have a quadratic. So this is easy enough to factor, hopefully. Hopefully it factors straight up. I put x and x. If it factors a 20, 1 and 20 is not going to work. 2 and 10 is not going to work. 4 and 5, that'll work. 4 and 5. And then I say, well, is it plus plus or minus minus? Because I got to have a positive 20 at the end. It's got to be plus plus. And I multiply them to check that that's x squared plus 9x plus 20. And sure enough, it is. So there it is in factored form, which also means, remember, this was the original function. So what are its zeros? Since we know the factored form, so the zeros, or the x-intercepts, are 1, negative 4, and negative 5, all from the factors. All right, so this function hits at 1, 1, -4, and -5, right? It's a third degree, positive leading coefficient, so it goes down to the left, up to the right, so it's got to come up, cross through there, and then eventually come back up that way. That's kind of what that third degree would look like if you were actually graphing it. Okay. Oh, that's our factored form, by the way. Get that over there. All right, so this one's a fourth degree polynomial. So we'll have 4 zeros. Hopefully they're all real, but they're not always all real. We'll talk about real and non-real zeros later, but fourth degree. So what are our possible rational zeros? What are our possible rational zeros? Let's say factors of the constant on the end, 6 over factors of 3. Remember, factors of 6 are 1 and 6, 2 and 3, plus minus on those, right? Factors of 3 are just 1 and 3. So let's list the possible rational zeros that we're going to then use to test. So I'm going to go plus minus, I'm going to go 1 over 1. Then I'm going to go with 2 over the 1. Then I'm going to go the 3 over 1, then the 6 over 1. Then I'm going to do all those same ones, except I'm over 3 now. Plus minus 1 over 3. The other factor of 3. Plus minus the 2 over the 3. Plus minus the 3 over the 3. And finally, plus minus the 6 over 3. Then I look at it and I say, is there any repeats here? Well, if you notice 3 over 3 is 1, I've already listed plus and minus 1. If you notice 6 over 3 is 2, I've already listed plus and minus 2. So those are just the repeats. So I'm left with 1 and -1, 2 and -2, 3 -3, 6 -6, 1/3 plus minus, 2/3 plus minus. So it looks like I have, 12 of them total, 12 possible zeros, 12 possible zeros. So it says find the zeros using synthetic division. Well, here's our function. So while we're finding zeros, we can go ahead and also factor it too, right? We're trying to find the zeros of this. So we can start out with -1, then we'll go to +1 if that doesn't work, and so on. But let's see what happens. So let's try -1. Actually, you know what? Let me do +1, and then I'll go to -1. Let's try +1. So 3, -11, -1, 19, and 6. Does 1 work? If 1 works, then x minus 1 is a factor. If it has a remainder of 0, right? So let's go ahead and drop the 3 down. 3 times 1, 3. -11 plus 3, -8. -9. 10. Okay, that one does not work, right? Because I did not get a 0 as my remainder. So x minus 1 is not a factor. So let's move to -1 now. Let's try -1. Does -1 work? If -1 works, then x minus -1 is a factor. Yeah, so let's see if it works. 3, -3, -14. Hey, it does work. So let's put that quotient in. So this will be 3x to 1 degree less to the third minus 14x squared plus 13x plus 6. Let's put that in right here. 3x to the third minus 14x squared plus 13x plus 6. Okay. Now, sometimes you can have a repeated 0. So we're going to try -1 again and see if it works with this. Let me give myself a little room here with the next one. So now we're breaking down. So this is what we have. We have x plus 1, and we're trying to break this one down now. Let me do it in red now. We're trying to break that down now. And like I say, sometimes you'll have a repeated 0. It means it just touches right there. So let's try -1 again and make sure it's not a repeated 0. So now I'm using the coefficients 3, -14, 13, and 6. And let's just make sure it's not a repeated 0. So 30. Okay, no, it's not. -24. Okay, so -1's done with. We've already used up -1. So let's move to -2 now. Let's try -2. Again, I'm using the coefficients 3, -14, 13, and 6, right? And let's see if -2 is a 0. Okay, so it's not. -2 does not work. Okay, so we've run through 1 didn't work. -1 worked. We used it. We factored it. -2 did not work. Now as we're breaking down the rest of it, because it's a third degree, right? Since it's not a quadratic, I can't just factor it straight up. So -2 did not work. So now I'm moving on to +2 on my list. And let's try this one. Hey, there it is. Okay. So it'll be 3, and it'll be 1 degree less than that 3x to the third. So 3x squared minus 8x minus 3. 3x squared minus 8x minus 3. And now that we have a factor, now that we have it down to a, oh gosh, I'm so sorry guys. I forgot to write 2 is a 0 before I write that. So x minus 2 is a factor of this. So x minus 2 is a factor, and then I got to put in my, sorry about that, 3x squared minus 8x minus 3. There we go. So here's what we have. X plus 1, x minus the 2, because 2 is a 0, 3x squared minus 8x minus 3. And this is a quadratic, so we'll just factor this quadratic. So 3x and x, and it's got to be 3, 1. It looks like that'll have to be negative, that a positive. Check that. 3x squared minus 9x plus x minus 3. There you go. So there it is, completely factored. So there's our zeros. So x plus 1 equals 0. So -1, 2, -1 third, 3. There's all 4 of our zeros. And we did already factor it. Here was the function, 3x to the 4th. So it was x plus 1, x minus 2, 3x plus 1, and x minus 3. There it is in factored form. All right, let's keep repeating this process. And first of all, let's list our possible rational zeros, which would be factors of the 4 over factors. It looks like I just have a 1 in front there. So this will be pretty easy. So we know factors of 4, 1 and 4, 2 and 2. Factors of 1 are just 1 and 1, right? So we'll have factors of 4, again, plus minus on this. So plus minus, I'm going to go 1 over the 1, plus minus a 2 over 1, plus minus a 4 over 1. So I only have 6 possible rational zeros. So when we're breaking this down and factoring and finding the zeros, make sure I copy this right. Let's go ahead and let's start with, we'll start with -1. Let's see if -1 works. 1, 4, 3, -4, -4. Hey, it works. So -1 is a 0. So x minus -1 is a clean factor. and I put my answer right there. So it'll be 1x 1 degree less, 1x cubed, 3x squared, 0x minus 4. Okay? So now we have x plus 1, and then we're breaking this one down, and we're testing that. Now let's make sure that -1 is not a repeated 0. So let's test -1 again. So I'm going to go 1, factor 1, 3, 0, -4. And let's see, make sure that's not a repeated 0. It's not. Okay, so we're done with -1. So let's move to +1 now. Let me erase this. So let's see if +1 works. Next one on our list, right? So we've used, remember our list is -1, +1, -2, +2, -4, +4. We're done with -1. It was a 0. Now we're moving on. It was not a repeated 0. So again, I tested it again. Now let's try 1. And again, we're using 1, 3, there's 0x minus 4. That's what we're factoring, right? Get rid of this. Hey, it works. So 1 is a 0. So x minus 1 is a factor of that x cubed plus 3x squared minus 4. Let's put our answer in, our quotient. So it'll be 1x 1 degree less, 1x squared plus 4x plus 4. Now I have a quadratic. So I have x plus 1, x minus 1. I have this quadratic that I can factor into x plus 2, x plus 2. X plus 2 will give us x squared plus 4x plus 4. So what are our zeros? Here's our factored form. What are our zeros? -1, 1. It looks like I have 2 of these -2. So x equals -2 with multiplicity of 2. All right, what does that mean with multiplicity? Well, if you remember, graphically what this means is you hit -1 once, you hit it 1 once, but you hit it -2 twice. There's 2 of those. So it either touches it or touches it from the bottom. And this is originally a 4th degree with a positive leading coefficient. So I know it goes up to the left and up to the right. So it's got to come down. It's got to hit this. Then it's got to come down, be smooth still, hit this. And then it's got to sometime come back up to go through there. So I know it doesn't touch from the bottom. Graphically. I know this is not asking us graphically, but I think it's helpful to do that. Well, here was our function. And if here was our factored form, then I had 2 of these x plus 2s, right? That was our factored form. All right, this one's a little different. It gives us a function, it's a 3rd degree, and it tells us f of 1/4 is 0. In other words, it's telling us one of the zeros. So let's go ahead and start. Let's list the possible zeros. Possible rational zeros again. Let's just make the list. So it's factors of 1 over factors of 12. Well, factors of 1 is just 1 and 1, right? Plus or minus. Factors of 12, on the other hand, you have 1 and 12. You got 2 and 6. You got 3 and 4. All right, and there's all our possible. I'm sorry, those are all our factors of 12. So let's write our list of possible zeros, rational possible zeros. Well, factors of 1 plus minus 1 over the 1. So I'm going 1 over 1, then I'm going 1 over the 2, 1 over the 3, and so on. There's our list of 12 possible zeros in this case. 12 of them, 1, -1, and so on. they're given, note, you're given f of 1/4 is 0. So I'm like, oh, that's nice. Then I don't have to start, is it 1? Is it -1? Is it a half? Is it -1/2? And so on. They give us that 1/4 is one of them. So I'm going to go ahead. Well, let me write the function here. I got breaking down 12x cubed, 13x squared minus 1. Right? We're trying to factor that. 1/4 is a factor. So x minus 1/4, I'm sorry, 1/4 is a 0. So x minus 1/4 is a factor. Let's put the leading coefficients in. 12x cubed, 13x squared, 0x, constant's -1. Drop the 12 down. 12 times a fourth, 12 fourths is 3. 13 plus 3 is 16. 16 times a fourth, 16 over 4 is 4. 0 plus 4, 4 times a fourth, 4 fourths is 1. And you notice, sure enough, it is a 0. But we had to do the synthetic division to write in 12x, it'll be 1 degree less, plus 16x plus 4, right? And notice, before I start factoring this next one, notice I can take a 4 out of each of those. So 12x squared, that'd be 3x squared plus 4x plus 1. And let me put the 4 in front. And finally, let's go ahead and factor this. So 3x, 1x, it's got to be 1 and 1. Positive times a positive or negative times a negative. This one works out to be positive times a positive. And so there's our factored form. And if you want, you can also, well, let's go ahead and find our zeros. So I have a fourth, -1/3, and -1. There's all 3 zeros for that third degree polynomial. So here's our factored form. And notice you have x minus a fourth. So sometimes if this will multiply through and give you integers, you'll oftentimes see them put it this way instead. So it's clean without rationals, fractions, right? So there's the factored form. All right, guys, the intermediate value theorem says if you've got a polynomial function, so smooth and continuous is a polynomial function, and a is less than b, let's put a here, let's put b here, a is less than b. If f of a and f of b have opposite signs, like let's say f of a is down here, it's negative, f of b is positive. Again, this is some polynomial, so I don't know what it looks like, but it's smooth and continuous. Then, if they change signs from f of a to f of b, we know you've got to have a 0 in between them. It's got to cross the x-axis, right? So this first example, determine whether the intermediate value theorem guarantees that the function has a 0 on this interval. Well, let's plug in 0 and let's see what we get. So it looks like I got 0 plus 0 minus 1. It looks like I got -1. F of 0 is -1. So here's that point, 0, -1. Now let's throw in the 1, the other end of the interval. Remember, this is going from 0 to 1. So 12 times 1 cubed plus 13 times 1 squared minus 1. So I got 12 plus 13 minus 1. It looks like I got 25 minus 1, 24. So 1, it hits clear up here, 1 kind of 24. So I don't know what this looks like, but between the two, I'm going from a negative to a positive, so it's got to cross between them. So I say yes, it must, since f of 0 is less than 0 and f of 1 is positive, they change signs, then by the intermediate value theorem, there exists So what that mean? A 0 on the interval from 0 to 1. Or another way to say that is, let me write it with a little. There exists a c in the interval from 0 to 1 such that f of c equals 0. That's a little better way to say that, actually. Let's try this one. How about from 1 to 2 for this one? Let's throw 1 in. Looks like f of 1 ends up being 8. And let's throw in f of 2. F of 2 would be 8 times 2 to the 4th minus 3 is 2 squared plus 4 times 2 minus 1. Let's see, 2 to the 4th, 16. 3 times 4, 12, plus 8 minus 1. I don't know, 16 times 8. Minus 12 plus 8, -4 minus 5, so 123. F of 2 is 123. So f of 1 is a positive 8. F of 2 is a positive 123. So since f of 1 is positive and f of 2 is positive, they're both positive, there's no conclusion can be made. They have to change signs. So no conclusion can be made about the zeros on 1 to 2. Okay? All right, thanks so much for watching. See you next time.